Welcome everyone to a quick overview of lesson 1.16 from calculus, which is the intermediate value theorem. If that sounds familiar, it probably should. We used it in pre-calculus to find zeros. So let's examine it through that lens, shall we? I have a nice partial parabola here, and I've cut it off at 1, and I've cut it off at 6. So those are the x values we're going to use. So we're going to examine this through the lens of 1 to 6. Well, at 1 it outputs negative 1.5, and at 6 it outputs 1. So by the intermediate value theorem, there should exist at least one zero between them, and we can see that it does indeed exist, and it exists at this 1.551. That's pre-calculus. Calculus is, well, this one outputted negative 1.5. This one outputted 1. We could say any value between 1 and negative 1.5 should exist for any of the inputs, so long as, again, the same conditions apply for how you used it in pre-calculus, that the function is continuous. And we can see that it is, and we indeed have x values that give us everything between negative 1.5 and 1. They do all happen to be right here. We do get some values outside of that, but the intermediate value theorem is all about guaranteeing things, and we could not have guaranteed this. This is just something that happened, and that's great, but we couldn't guarantee it. But we could guarantee everything between negative 1.5 and 1. So again, pre-calculus was we could guarantee a 0. Calculus is I could guarantee anything I wanted between negative 1.5 and 1. So let's look at a different function. Let's look at this function here, which is a very pretty sine curve that is increasing over time. A little interesting. So this is sine of x plus x. So at 1, the function outputs a 1, and at 6, the function outputs a 6. So 1 outputted a 1, 6 outputted a 6, and that means by the intermediate value theorem, any y value between 1 and 6 is guaranteed by the function. And we can see we can get any y value between 1 and 6. In fact, we get some of them multiple times, but every single one of them is guaranteed. Now, what I could not guarantee is I could not guarantee a 0. And in fact, you can see here, we don't have one. But again, because the function outputs a 1 and a 6 on the ends of my interval, which is 1 to 6, I can guarantee any y value I wanted. There's a y value of 2. If it'll work for me. I guess not. Y value of 2.5, y value of 4. I can guarantee anything I want in between the interval. But for example, I could not have guaranteed this 0.6, 0.5. I could not guarantee that at all because, well, it's not between 1 and 6. Let's look at one where we really couldn't guarantee anything. Again, this one's continuous. Let's look at the last example. This one, it's rational. It's not continuous. So even though my endpoints here are 1.667, so 5/3, and 2.5, if it was continuous, I could say I can guarantee anything between 5/3 and 2.5, but I can't because it's not continuous. And as you can see, I actually don't have any values in between them. I have all the values outside of them, which I couldn't have guaranteed anyway with IVT. Like we have a 0, we have these values outside of the interval, but nothing in between the two y values. And again, we couldn't guarantee it because, as we can see, it's not continuous. That is it for IVT. So good luck to you on your practice, and I will see you in the next video.